Question number 12. A spring ball of mass 0.5 kg is dropped from some height. On falling freely for 10 seconds, it explodes into two fragments of mass ratio 1:2. The lighter fragment continues to travel downward with 60 meters per second. Calculate the kinetic energy supplied during the explosion. Now, what is the spring ball first of all? Spring ball means that two hemispheres connected with the help of a spring, and then when you compress it, the spring inside it gets compressed, and these are the balls. These are two hemispheres. Okay, so after explosion, when it explodes, one part goes to the right side, other part goes to the left side, and then finally it oscillates. So in this particular case, the spring ball, both the hemispheres are not of equal masses. The ratio is 1:2. So one is heavier, other is lighter, right? This spring ball, which is initially compressed and released from certain height, it travels for 10 seconds. Now, normally on Earth, what happens if you drop anything? On Earth, you will experience that after every 1 second, uska speed increases by the value of g. Means if you drop a ball from certain height, initial speed 0 hai. Time 1 second ho gaya, uska speed will become, its speed will become 9.8 or 10 meters per second. 2 सेकंड के बाद 20, 3 सेकंड के बाद 30, 4 सेकंड के बाद 40. Every 1 second, its speed is going to increase by 10. So orally you can calculate this part, that the speed of that spring ball after 10 seconds will be 100, right? So when the spring ball is released from certain height, after 10 seconds, what is the condition? Uska speed is 100 meters per second. So what is the momentum of that ball at that particular instant? The momentum of the ball will be mass times velocity, that is half into 100, that is 50 kg meter per second in downward direction. This will be the momentum of the system. Before explosion, uska ye state hai at t equal to 10. Let us also calculate uska kinetic energy kitna hai us time pe. Its kinetic energy is half mv square. So half, uska mass is also half, 0.5 kg, and uska velocity is 100. 100 ka square is 10,000. So if you solve it properly, you will get 2,500 joule. Uska kinetic energy is 2,500 joule, right? So before explosion takes place, the momentum and kinetic energy of the spring ball is in this way. Now over here, after 10 second explosion takes place, explosion mein two masses are present, a lighter one and the heavier one. Lighter one and heavier one ka ratio is given. The lighter one ka mass will be what? See, 1:2 ratio, right? So 0.5 kg को अगर split करेंगे 1:2 में, तो this will become 0.5 by 3, that is the 1/3, and this will be 2/3. 2/3 mass यहाँ पे है heavier particle को, ये lighter particle है 0.5 by 3. So lighter particle जो है, let us say this one is lighter particle and this one is heavier particle. Lighter particle का mass is 0.5 by 3, which is 1 by 6. 0.5 already is 1 by 2, so 1 by 6. और heavier particle जो है उसका mass 2 into 0.5 is 1. Heavier particle का mass is 1 by 3. So lighter particle continues its journey with the 60 का speed. So lighter particle का momentum after, this is before and after explosion, momentum कितना होगा system का? Momentum should get conserved. So lighter particle का momentum कितना है? उसका mass lighter का into velocity of lighter plus mass of heavier into velocity of heavier. दोनों का addition should be 50 in downward because momentum cannot change. Externally no force was acting. So what is the mass of lighter particle? It is 1 by 6 into what was the velocity? The velocity is given. Lighter particle moves with 60 in downward direction. So momentum is 10 kg meter per second. In which direction? Downward. So इसका कितना होना चाहिए? It should be 40. ये 10 तो ये 40 होना चाहिए to make it 50. So if this should be 40, उसमें से ये कितना है? ये तो 1 by 3 है. The mass of heavier particle is 1 by 3. So what should be its velocity? Its velocity should be 120. If its velocity is 120, then the multiplication will be 40 and 40 plus 10 will give you 50 and the momentum will get conserved. So after collision, before collision the momentum was 50. after explosion, the smaller particle moves with 60, the heavier should move with 120, so that to keep the momentum same. So heavier particle का speed 120 है, lighter particle का speed 60 है. In this process, the momentum is conserved, and hence we have calculated the speed of the heavier one, right? Heavier one का speed मिल गया. The question is, calculate the kinetic energy supplied during the collision. Before collision, the ball का kinetic energy was 2500. After collision, after explosion, sorry, I'm repeating the word collision. After explosion, what is the kinetic energy? The kinetic energy of these two balls separately will be half mLVL square plus half MHVH square. इसका kinetic plus इसका kinetic है. If you add them, half lighter particle का mass is 1/6, right? It is 1/6, and उसका velocity 60 का square is 3600 plus half mass of heavier particle is 1/3 into उसका velocity का square is 120 square is 14400. And if I add these two numbers, 600 and 600 by 2 is 300. So the first kinetic energy is 300. छोटे वाले particle का kinetic energy is 300. Heavier particle का kinetic energy will be, this is 6 24 za, so it is 2400. 300 plus 2400 is the energy of the heavier particle. So total energy कितना है? 2700. Originally energy was 2500 before explosion. After explosion 2700. So ये extra 200 जो है, this energy is the energy supplied during the explosion. Which quantity? The extra 200 is provided by what? It is provided by the spring inside this spring ball. The spring had stored that energy 200 and it provides that energy during the explosion, and the kinetic energy supplied during the explosion is 200 joule. So the answer for question number 12 is 200 joule. Question number 13. Marble of mass 2m is traveling at the speed of 6 centimeters per second. So this is marble of mass 2m and this is traveling at the speed of 6 centimeters per second, and this followed by another marble of mass n. Now the smaller one is of mass n. It is traveling with double speed. Double मतलब ये 6 है, so this will be 12 centimeters per second. Okay, they collide with each other. This is traveling with higher speed, so this will collide with the first one. Second one, m will collide with 2m, and after collision the heavier one travels with heavier one, lighter one and heavier one. The heavier one travels with the average initial speeds. इन दोनों का average 6 and 12 का average speed से this will travel, means this will travel with the speed of 6. 12 का average is 9. This will travel with 9. Calculate coefficient of restitution. So first we have to calculate किसका speed क्या होगा, right? So you can consider this speed as v, and conservation of linear momentum. Any type of collision it might be, elastic, inelastic, but momentum is always conserved. So what is momentum before collision? Before collision, the momentum is m into 12 plus 2m into 6, right? 2m into 6, m into 12. No need to convert the units because everywhere the units are same, is equal to m into v plus 2m into 9. 2m into 9 is 18m. So cancelling all m's, this will become 24. 24 is v plus 18. So v is equal to 6 centimeters per second, as the unit was centimeters per second everywhere. This will also be in centimeters per second. And once you get velocity of the first ball after collision, what is the formula for coefficient of restitution? Coefficient of restitution, we have seen, it is the ratio of velocity of separation. It is the ratio of relative velocity of separation to relative velocity of approach. So while separating, what was the relative velocity of separation? This is moving by 9, this is moving by 6, we have calculated. So the relative velocity is 3, and inka relative velocity is, this is approaching this by 6, so relative velocity is 12 minus 6 is 6. So the answer comes out to be half, that is 0.5. Coefficient of restitution is a unitless quantity. So coefficient of restitution for this question answer is 0.5. So next one is question number 14. A 2-meter long wooden plank of mass 20 kg is pivoted at 0.5 meters from either ends. So there is a 2-meter long wooden plank. This is 2-meter long wooden plank. The span is 2 meters and 0.5 meter from both the ends. दोनों ends से 0.5 meters पे there are supports. This is 0.5 from this end, 0.5 from this end. So this distance is 0.5. This distance is 0.5. So obviously this distance will be 1 meter, as the total span of total length of this plank is 2 meters. The mass of the wooden plank is 20 kg. The mass will always act, the weight will always act from its center of mass. So how much weight will act? 20 kg is 200 Newton. Right from the center it will act. A person of mass 40 kg starts walking from one of the pivots to the farther end. So suppose person is standing over here and the person starts walking to the farther end, the other end, not the closer one, the farther end. If the person starts walking, how far the person can walk before the plank topples? Now this is quite logical question. We know that as the person will start walking from, let us say this is location A to B. If the person is traveling from A to B, there is no location where the plank will topple. Plank will only topple if the person crosses B and then goes further, right? If the person crosses this point B and goes further. यहाँ पे जब जाएगा, at that time, because of his weight, the plank can topple. Plank will topple when the person will cross this location B. B के पहले plank is not going to topple. So let us say this person travels distance x distance के बाद it is going to topple. So if it is going to topple after traveling distance x, what is the value of x? And see, for this particular question, if the person travels distance x, when the plank will topple, it is going to rotate about this point C. So about this point C, the plank is going to rotate. Sorry, about this point B, the plank is going to rotate in this way. It means when the plank is at this particular, when the person is at this particular location, person की वजह से जो torque है and weight की वजह से जो torque है, they will be exactly equal. See, I'll explain this using the force diagram. When the person will reach at this position, from this point he will cover distance x, right? The person will cover distance x. So from point B, कितना distance रहेगा ये? From point B, this distance will be x minus 1. This distance will be, because this distance is 1, between A and B the supports distance is 1. So this particular distance beyond B, the distance will be x minus 1. So about point B, if you think, about point B, how many forces are trying to rotate B? Yes, A is trying to push it up. इसका weight 200 Newton is trying to push it down, 200 Newton. And the person का weight is also trying to push it down, which is 400 Newton, which is large. Plank यहाँ तक है, right? So there are three forces. But the moment when the person will just go at distance x, when the plank is just about to topple, this force will become 0, because now it will just try to lose the contact from A. When it will start rotating, it will just lose the contact. So यहाँ पे there will be no contact. So यहाँ तक there is no reaction force. Only two forces will act: weight and इसका weight. Weight of the plank, weight of the person. So weight of the plank कितना torque apply कर रहा है? The torque applied by the weight of the plank. The plank is applying 200 into this distance is half into 0.5, that is 100 Newton meter in anti-clockwise sense. Whereas the person is exerting torque of 400 into 1 minus x, sorry, 400 into x minus 1 in clockwise sense. जब तक this torque is greater, the plank is not going to topple. Even when these two are equal, the plank is not going to topple. It will just topple when it will exceed the value. So x का maximum value कब तक the plank is not going to topple? We need to equate them. So if you equate these two things, 400 will go in denominator, and 1 by 4 का value is 0.25 is x minus 1. So x will be 1.25 meter. So the person can walk from this point to this point, and which is 1.25 meters. He can walk without the plank topples. Once he crosses 1.25 meter, the plank is going to topple because his weight ka torque will be greater than the weight of the plank ka torque. So the answer for this question is 1.25 meters. Question number 15. A 2 meter long ladder of mass 10 kg is kept against a wall such that base is 1.2 meters away from the wall. So a ladder is placed on a wall. This is the side view. So this is floor and this is wall. And on this wall a ladder is placed, and ladder ka length is 2 meters. Ladder's length is 2 meters. The ladder is placed in such a way that it is 1.2 meters away from the wall. Wall se 1.2 meters away. So if this is 1.2, this is 2, by Pythagoras theorem, you can calculate this. You will get the answer as 1.6 meters. Right? So it is given that the wall is smooth. There is no friction over here. The wall is smooth, but the floor is rough. If the wall is smooth and the floor is smooth, the ladder will automatically slip and fall down. But since the floor is rough, it will provide certain friction in opposite direction. It will avoid the sliding. The roughness is maximum half of the normal reaction. यहाँ पे जो normal reaction है, ladder or floor. Remember, the normal reaction is always perpendicular to the surface. यहाँ पे normal reaction will be upward, and over here the normal reaction will be in this way. Normal reactions are always perpendicular to the surface. So normal reaction N के half times the friction roughness is. Roughness is maximum up to half the normal force. So this frictional force will be maximum up to half N. A monkey of mass 20 kg starts climbing the ladder. How far it can climb along the ladder? As the monkey will start climbing, how much maximum distance he can go, or how much maximum distance the monkey can travel along the ladder before the ladder starts slipping? So that is the first question. So let us consider if the monkey travels up to distance x. This is the distance x. Up to distance x if the monkey travels. After that this ladder is going to slide. Then what is that value of x? That is the first question. Okay, the monkey ka mass is 20 kg. So uska weight will be 200 Newton. And ladder ka mass is 10 kg. So uska weight will be acting exactly from center. It will be 100 Newton. Barabar? This is normal reaction N. This will be N by 2. So for equilibrium case, all forces should cancel, all torque should cancel. So let us deal with forces first. Sum of all forces should be 0 for equilibrium. And therefore, sum of all forces along x should also be 0. Sum of all forces along y should also be 0. Means vertically forces should cancel, horizontally the forces should cancel. Right? So vertically kitne forces hai? 200, 300, n. Sorry, 200, 100 and n. ये vertical forces है. n by 2 और ये horizontal reaction, ये horizontal forces है. Right? So vertical forces should be 0. Means if downward is 300, upward should be 300. From this you will get n is equal to 300 होना चाहिए. And the reaction is maximum up to half the normal reaction. So the reaction should be 150. So ये भी 150 होना चाहिए. 150 will cancel out. So even this one should be 150. So horizontal reaction should be 150 H. Horizontal reaction should be 150. Normal reaction at vertical should be 300 Newton. Now the question is maximum how much the monkey should climb. For that we need to use the second condition of equilibrium, that the sum of all torque should be 0. You can choose any location about which you have to calculate the torque. The torque should be 0 about that location. So I will choose that location where maximum number of forces are there, that is this location. If I take torque about this location, I should get net torque 0 because the system is in equilibrium. So if I draw free body diagram of that ladder, how many forces are acting? If I consider this as the axis of rotation, clearly this force and this force are not going to participate in rotation, so I won't draw those two forces. 100 is going to participate, 100, yes. Even 200 is going to participate, yes. And even this 150 is going to participate, yes. This 150 and this n is not going to participate because उसी point से axis of rotation present है. Out of these three forces, how many are clockwise? This is anti-clockwise. This is also anti-clockwise, and this is clockwise. So इन दोनों का torque anti-clockwise है, इसका torque clockwise है. They should cancel out so that net torque should become 0. So इन दोनों का torque I'll calculate first, right? So 100 वाले का torque कितना होगा? 100 is the force into what is the perpendicular distance? This distance is how much? If this distance is 2, see, if the total distance is 2, this distance is 1.2. If this distance is 1, because center of mass will be at the center, this distance will become 1.2 ka adha, that is 0.6. So the torque because of 100 will be 100 into 0.6, in which sense? Anti-clockwise sense. This is the torque because of 100. Up to 100 ka torque. How to calculate 200 ka torque? 200 into what will be this distance? This distance. So अगर 2 मीटर के लिए, for 2 meter, whole length is 2 meter, then the total distance is 1.2. If the whole length is only x, what will be this distance? It will be cross multiply. It will be 1.2 x by 2. That is 0.6x. That is 0.6x. And on multiplying this, you will get 120x. And this torque is also in anti-clockwise sense. This is 60. This is also in anti-clockwise sense. These two torques are in anti-clockwise. And these two torques should be equal to the clockwise torque of this 150 Newton. 150 Newton का torque कितना? 150 Newton का force कितना torque act करेगा? For that, I need to calculate force, which is 150 into perpendicular distance of the force from the axis of rotation, perpendicular distance, which is equal to 1.6, which is equal to 1.6. So on calculating this, 150 into 1.6 is 240, 60 plus 120x. So 60 will go to the right side, वो हो जाएगा 180 is 120x. Therefore, x equal to 1.5 meter. The monkey can travel maximum up to 1.5 meters. Because if you go beyond 1.5, this counterclockwise will increase and the light is going to slip further. So the answer for question number 15 is 1.5 meters. Okay, so next question is question number 16. 4 uniform solid cubes of edge lengths 10, 20, 30 and 40 centimeters are kept on the ground touching each other. Locate the center of mass of the system. So on horizontal ground level, 4 solid cubes are placed. So from the front view, you can observe it. It will appear as a squares. So this is the first cube. Its length of each side is equal. It is 10 centimeters. The second one is 20. The third one is 30. And the fourth one is 40. So 10, 20, 30, 40. These are the 4 cubes placed on the ground. Okay, so let us treat this particular axis as y-axis. Okay, it should pass from this point, and this axis as x-axis. And we have to plot the center of mass. So first of all, what will be the masses? Whether it will be m, 2m, 3m, 4m, or how to calculate the mass of 4 cubes. As we know that mass of a cube is volume times density, because all the cubes are solid cubes and they have same density. So mass is proportional to their volume as density is same. So इसका volume जो है, volume is L cube, right? So इसका volume, if it is 10 cube, this will be 20 cube, this will be 30 cube, and this will be 40 cube. So if I consider, for simplification, if I consider first वाले cube का mass is m, second वाले cube का mass will not be 2m or 3m, it will be straight away 8m, because length के cube पे dependent है. As length is double, volume will be 8 times, and volume will be 8 times, so mass will be 8 times. So इसका mass will be 8m, इसका mass will be, as the length is 3 times, the volume will be 3 cube 27, so the mass will be 27 times, 27m, and iska mass will be 4 cube 64 times. So these are the masses. And what will be the center of mass ke locations? Yes, in iska center of mass will be at 5,5, because 10 centimeter uska exactly center pe center of mass hai 5,5. इसका सेंटर ऑफ मास विल बी वर्टिकली 20 है तो वर्टिकली तो 10 आएगा, बट हॉरिजॉन्टली भी 10 आएगा, बट फ्रॉम दिस इट विल बी 10, राइट? 20 का हाफ 10, ऑलरेडी दिस इज 10, सो दिस विल बी 20,10. हाउ टू कैलकुलेट इसका सेंटर ऑफ मास? वर्टिकली उसका लेंथ इज 20, उसका हाफ दैट इज 10, बट हॉरिजॉन्टली इट इज ऑल्सो 20, उसका आधा 10, बट ऑलरेडी दिस इज 10, 10 प्लस 10 इज 20, सो 20. व्हाट विल बी इसका सेंटर ऑफ मास? इसका सेंटर ऑफ मास वर्टिकली उसका लेंथ 30 है, सो वर्टिकली हाफ कितना आएगा? 15, बट व्हाट विल बी हॉरिजॉन्टल भी 15 आना चाहिए, 15, बट 15 तो यहां से 15 है, प्लस दिस इज ओरिजिनली 10 प्लस 20, ये 30 है ओरिजिनली, 30 प्लस 15 इज 45. एंड सिमिलरली इसका सेंटर ऑफ मास क्या आएगा? इसका सेंटर ऑफ मास आएगा 40 है ये, सो वर्टिकली 40, हॉरिजॉन्टली 40, वर्टिकली 20 आएगा हाफ, हॉरिजॉन्टली भी 20 आएगा, बट 20 में you have to add this 10, 20, 30, that is 60, and 60 plus 20 is 80. So basically 4 cubes के 4 center of masses I have plotted with their masses. So now we have the system of 4 masses, m at 5,5, then 8m at 20,10, then we have 27m at 45,15, and then we have 64m at 80,20. How to find xcm and how to find ycm? What is the formula of xcm? xcm का formula is m1x1 plus m2x2. I will write the formula: m1x1 plus m2x2 plus m3x3 plus m4x4 up to mnxn. लेकिन यहाँ पे 4 ही terms है, divided by addition of all the masses, right? Similarly y के लिए same formula. I will use the formula now directly. If I put the values, m into 5 is 5m plus 28 are 160m plus 45 27 are 45 27 very difficult. 45 27 are 7 5 35, 28 31, 10 8 9 5 1 12 15m plus 64 into 8. 64 into 8 is 512. 5120m, because 80 है, it is not m. It is not 8, it is 80. Upon sum of all the masses, 64 plus 27 plus 8 plus 1. What is 27 plus 8? 27 plus 8 is 35 plus 1 36 plus 64 is 100m. And now if I solve this, if I add all the numbers, कितना मिलेगा? 520. I will add them separately over here. 5120, 1215, 160 and 5. Addition of all these numbers: 5 5 10. This is 4 6 10, and 2 4 5 and 6 6500m. 6500m upon 100 is equal to m will cancel, 100m was in denominator, so the answer is 65. So location of xcm we have what? That is 65. कहाँ पे है 65? Somewhere between, actually 65 इसमें आएगा, इसमें, because 10 20 30 is 60. 65 में इस block में, last block में somewhere the mass is x location. Similarly ycm you have to calculate. ycm will be m1 y1 5m plus m2y2 80m plus m3y3 27 into 15 27 into 15 separately calculate करेंगे 27 into 15 15 7s are 105 15 ones to the 30 40 405m plus 64 20s are 1280m divided by addition will still remain same 100m, right? And now if I add all these terms, what are those four terms? 5 80 85 85 plus 405 405 is 490 490 plus 1280 is 1170 1770 m is the addition of numerator upon 100 m will cancel 0 cancel, answer is 17.7. this is the YCM. So XCM center of mass location is 65, 17.7. it will be somewhere 65 मतलब 60 के ऊपर and 17.7 will be 20 के थोड़ा अंदर, somewhere over here. This is that location of center of mass 65, 17.7 centimeters as it is centimeters. So this is the location of center of mass for the system. Okay, question number 17. A uniform solid sphere of radius r has a hole of radius r/2 drilled inside it. One end of the hole is at center of the sphere while the other is at the boundary. Locate center of mass. So in this question, actually the question is in this way. It should be asked in this way. If there is a sphere of radius r, this is a sphere 3D, right? From this sphere, a sphere is removed. It is not drilled. The sphere is removed such that one end of the sphere is at the center, other end is at the boundary. So automatically the radius of this another removed sphere will be r/2. But in this question it is given that the hole is drilled. Now the problem with this hole drilled is, if you drill the hole inside a sphere, from this view you can see it in this way. But from this view it will appear in this way. See, this is sphere. And if I drill a hole right from the top, it will appear in this way. Okay, so this part will go. This is that hole. So this section will go. From the top view, it will appear in this way. But from the side view, it will appear, and it is very difficult to calculate the center of mass then. So actually the question, even the answer will match for this question. The answer actually is given for the same question. Means the answer is given if a sphere is removed from a sphere, not a cylinder is removed. And actually it is not even a cylinder. You can see, when you will remove that shape, uska surface will be somewhat in this way. This surface will be in this way. So it is not even a cylinder. So the question should be, from a sphere is removed, right? So we will solve the question for this way. Sphere is removed out of a sphere. This type of question. So this is a sphere whose radius is r, and from this sphere, a sphere of radius r/2 is removed. When you remove the sphere of radius r/2, this r/2 ka sphere if you remove, what will be the center of mass? Now this is x-axis, this is y-axis. Initially the center of mass was over here. So for the whole sphere, what was the center of mass? Center of mass was at origin 0, 0, right? And if you remove this particular sphere, the removed sphere ka center of mass kahan pe hoga? The removed sphere ka center of mass will be at r/2, 0, because uska ye removed sphere jo hai, uska center to r/2 pe hai. r/2, 0 will be the center of the removed sphere. So initially whole sphere hai, and then there is a removed sphere. I will use negative mass wala concept for calculating center of mass. What is negative mass wala concept? If this is a body, its center of mass is over here. If I remove certain portion out of it, then center of mass will shift towards left side, and it can be calculated by using the same formula. XCM is m1 x1 whole body ka mass into uska original coordinate plus m2 x2 upon m1 plus m2, but the only difference is the part which is removed, uska mass you will treat negative because it is removed mass. So negative mass consider karke I will solve this question. So now in this particular question, ये पूरे sphere का, ये red sphere का mass अगर m है, what will be the mass of the removed sphere? radius अगर half है तो whether mass will also be half? No. Mass, density, volume, you know the relation, we are solving these questions. Mass is density into volume. So if radius and mass में relation ऐसे है, mass is proportional to r cube. If I am removing a sphere of radius r by 2, the mass will be m by 8 and not m by 2. So the whole sphere का mass m है, तो ये removed sphere का mass कितना है? m by 8. And now using the concept of negative mass, I can solve this question using the formula of center of mass. xcm is m1, जिसका mass of whole sphere, into x1, which is origin, so into 0, plus m2, but it is negative mass, so minus m by 8, into x2, कितना है उसका लोकेशन? r by 2, m1 x1 plus m2 x2 upon m1 plus m2, m plus, लेकिन ये तो removed mass है, so minus m by 8. This will give you the location of its xcm. See, this is 0, so 0 minus, this will become mr by 16, right? 8 to the 16 divided by m minus m by 8 is 7m by 8. 8 to the 16 and it will effectively become mm will cancel minus r by 2 sevens are 14. So the center of mass का x coordinate will be minus r by 14. Minus sign indicates origin के left को गया वो. If you remove certain part of the sphere, obviously center of mass will shift towards left. And where will it shift? r by 14 to the left side, so negative side. Whether y coordinate is going to change, ycm is going to change? No, because इसका भी 0 है, इसका भी 0 है. Even if you put it in the formula, 0 0 आएगा. So ycm is not going to change. Basically center of mass will remain on x-axis. So the answer for question number 17 is minus r by 14. Minus sign indicates center of mass will shift to the left when you remove the sphere from the right side. So this is the answer for question number 17.